If you've ever heard the word Kubernetes and just pictured some impossibly complex piece of alien technology, I totally get it. But what if I told you it's actually as simple and kind of brilliant as a robot managing a tiny city? Yeah, let's break down exactly how that works. So, picture this. You've built an amazing new video game, and it doesn't just do well, it goes viral. Millions of people are trying to play all at once. Your servers are basically melting, the game is slowing to a crawl, and the whole thing is right on the verge of collapsing. How? How do you keep it fast, strong, and always online? That's the exact problem we're going to solve. All right, so the very first piece of our puzzle is something called a container. Now, the official definition talks about packaging code and dependencies, but let's just forget the jargon for a second. There's a much simpler way to think about this. Just think of a container as a perfect little lunchbox. You pack everything your application needs right inside it. The code, all the right tools, the specific settings, everything. And the beauty of this is you can take that lunchbox to any computer, open it up, and your app works perfectly every single time. It completely gets rid of that classic, but it worked on my machine problem. Okay, so you've got hundreds, maybe thousands of these neat little lunchboxes. Who on earth manages all of that? Well, that's where Kubernetes comes in. It's the system that automates the whole shebang. But again, let's just skip the official definition. Let's just call Kubernetes what it really is, a super smart robot manager. Its entire job is to watch over all of your application lunchboxes, make sure they're running smoothly, fix them if they break, and make more of them if you suddenly get a ton of traffic. This robot is the boss of our whole operation. So where does our robot manager put all these lunchboxes? Well, it uses a whole group of computers that are all working together. We call this group a cluster. And you can just think of it like a giant building full of shelves. Each individual computer in that group, that's a node, which is basically just one single shelf in our big building. Okay, let's zoom in a little closer now. In our robot city, the most fundamental building block isn't actually the container itself, it's something called a pod. This is the smallest single unit that our robot manager actually deals with. So you can think of a pod as a tiny little room where your container, your lunchbox, lives. Most of the time, it's just one container per room. But what if you have a couple of containers that are like best friends, and they absolutely need to work together side by side? Well, our robot manager is smart enough to know it should put them in the same room, the same pod. For example, let's say we have a simple app for showing cat pictures. You might have one container whose only job is to store all the image files, and then a second container whose only job is to display them on the website. I mean, they're useless without each other, right? So the robot manager places them together in the same pod, where they can easily work together. So we have our pods, our tiny little rooms. But how does the robot manager know how many rooms to create? It doesn't just guess. It uses something called a deployment. A deployment is simply a blueprint. That's it. It's a set of instructions you give to the robot manager. You tell it, hey, for my cat picture app, I always want exactly 3 pods running. No more, no less. And if one of those pods breaks, the robot just looks at the blueprint and goes, oops, I'm missing one, and automatically creates a new one to match the plan. Simple as that. Okay, so the robot is keeping our 3 pods running perfectly. That's awesome. But there's a problem. Pods are, well, they're temporary. They can be created and destroyed. And every time that happens, their network address changes. So how do your users find your app if its location is always moving around? This is where something called a service comes in to save the day. Think of a service as a single permanent phone number for your application. It just sits there, right in front of your group of pods, and directs all the traffic. It doesn't matter how many pods you have or how often they change behind the scenes. Your users only ever need to know this one stable address. The service handles the rest. So what happens when that one phone number gets a massive flood of calls? You know, when millions of players suddenly show up for your game. That's where a load balancer steps in to handle the rush. Imagine 300 players arrive all at once. Instead of just sending them all to the first pod and totally overwhelming it, the load balancer acts like a traffic cop. It distributes them evenly, right? It sends 100 players to pod 1, 100 to pod 2, and 100 to pod 3. This way, everything stays perfectly balanced and runs super smoothly. But what if 300 players turns into 3,000 players, or 30,000? Even with perfect load balancing, your 3 pods might not be enough to handle it.
you're going to need more of them. And this process of adding or removing pods to meet demand, that's called scaling.
And this is where our robot manager really gets to show off. You can actually tell it, hey, if the computers start working too hard, just create more pods on your own. That's autoscaling. The robot literally watches the system's health and automatically adds more pods during busy times and then removes them when things quiet down to save money. It's pure magic. Now, what about updating your game? You can't just shut everything down, right? Of course not. The robot manager handles this with what's called a rolling update, and it's incredibly careful. First, it brings up new pods with the new version of your app. Then it waits until they're perfectly healthy and working. Only then does it start to gently remove the old ones. And the result? Zero downtime. Your players never even notice. So how do we talk to our robot? Well, we could do it the imperative way, giving it this long to-do list of every single step. Do this, then do that, then do this. But the smart way, the Kubernetes way, is declarative. You just give it the final blueprint and say, make reality look like this. And then the robot figures out the most efficient way to get there all by itself. It's brilliant.
And there you have it. This is basically our cheat sheet for the entire robot city. The container is the lunchbox, the pod is the tiny room, the node is the shelf, and the cluster is the whole building. It brings all those simple analogies together into a perfect little summary of everything we've just covered. Which brings us right back to our big idea. If you remember just one thing from all of this, let it be this. Kubernetes is a robot city manager. It takes care of all your little application shops, making sure they're open for business, handling the crowds, expanding when business is good, and updating the storefronts without ever having to close down.
So you now understand the master plan behind some of the biggest applications in the entire world. And this isn't just about managing games. This is a blueprint for building resilient, scalable systems for pretty much anything you can imagine. The only real question left is, what will you build?